So one of the things you may have learned back in grade school was this idea of if you were to go ahead and give yourself, pinpoint your location. Okay, I'll go ahead and pinpoint my location here. You would talk about in terms of your latitude, okay, and your longitude. Latitude and longitude. The way I remember is that longitude are like long lines, and latitude kind of are what kind of like horizontal lines. I don't know if you're looking at the Earth like that anyway. So your lines of longitude and latitude. Now, you may or may not remember this, but actually, I bet you do. Lines of latitude actually begin at the equator. So the equator is 0 latitude, and they top out at 90 degrees latitude at both of the poles. So this is 90 degrees north, and this is 90 degrees south. Latitude. With regard to longitude, actually they begin at what's called the prime meridian, and they go west and they go east. Okay. And they meet at, this is one of my favorite things, they meet at the international date line. I just think that is so cool. So at 180 degrees longitude west and east, kind of wrap around. So, for instance, Miami is 26 degrees north latitude and 80 degrees west longitude, right? So here we have the celestial sphere with the cute little Earth spinning within that hollow sphere we call the celestial sphere, with stars imprinted on it. And so as the Earth spins, we already talked about this a little bit actually, as the Earth spins on its axis of rotation, that is why we see the sunrise and the sunset. Okay, because the Earth's rotation, that's called diurnal motion. Sun appears to rise in the east and sun appears to set in the west. That's also why we see the moon appear to move across the nighttime sky throughout the course of a night, because of the Earth's spinning on its axis of rotation. And I think I also mentioned that if you were to do open up your shutter, you would see these star trails, okay, over here. So you can kind of see this bullseye sort of thing going on, where in the northern hemisphere it is going to go counterclockwise. So if this is Polaris, which is actually the star that lines up, the star that our Earth's axis of rotation is right now pointed to, we would see, let's see, counterclockwise. Let's see, goes this way. Okay, we would see stars move counterclockwise. Okay. And in the southern hemisphere, there is no pole star. I think I mentioned that earlier. All right. Okay. So here we have a person standing in, looks to me like North America. Kind of hard to tell. But you can see kind of here, let me choose a different color. I'll choose green. Okay, this is that person's local sky. Okay, this is his or her horizons. That's their zenith. One thing about it is, if this person right here looks and finds Polaris, the North Celestial Pole Star, actually the angle that Polaris makes with the horizon is that person's latitude. Okay, so you've heard that in the past, like sailors would use sextants to look at the stars and the angle that the stars make with the horizon to check where they were with regard to latitude. That's actually how that's working. Let's see, what else do we want to say about this? So that's his local sky. Okay, circumpolar stars. So do you see where some stars, and this is where I need to kind of focus on this part of the figure, these stars right up here, okay, these stars are what we call circumpolar stars. Okay, circumpolar stars mean as the Earth, for this person with this local sky, as the Earth rotates, those stars will never, they'll be high and then they'll be low, but they'll never set below the horizon. They're always above the horizon. And your pole stars, your same set of pole stars, will be your pole stars as you orbit the sun. That is to say, throughout the year, they're going to be your same set of pole stars. Okay? So, yeah. So my other note on this slide I see is that, can you see where this person in this particular scenario, there are stars down here that he or she will never see. Specifically, oh, I like this figure. I never noticed that till just now. Okay, these stars down here are stars that they will never see. It's kind of analogous to the circumpolar stars that they always see at some time. They're always up. They're always above the horizon all night long. Okay, otherwise, stars that aren't circumpolar appear to rise in the east and set in the west, and or they tend to kind of take on this counterclockwise motion in the northern hemisphere around Polaris, the North Star. So I have some pictures here, some star trails. So if you were, picture this, this is one of my favorite pictures. Okay, just picture your, this polar bear just makes me smile. Just picture you are at the North Pole. Okay, so Polaris is at your zenith. Okay, so if you are looking for kind of the bullseye pattern in the star trails, actually you look up and you draw one circle, you draw a bigger circle, you draw an even bigger circle, kind of like I said what your star trails would be like. Now if you keep drawing circles, basically you're going to move your way down to the horizon and draw one big circle around the horizon. And so that's actually why this polar bear sees his star trails like that, is he is looking, I think I put on my slide, looking, doesn't really matter, looking west. Okay, actually he would see it anywhere. But now this does make a difference. So let's consider yourself at the equator, looking west. Now, if you're at the equator, first off, if you look for Polaris, okay, the equator is, check this out, this is all going to kind of come together. The equator is a latitude of 0 degrees. So remember that Polaris will make an angle with the horizon of whatever your latitude is. So Polaris is at 0 degrees. So with your horizon, so Polaris is on your horizon. Okay, so with that in mind, go ahead, Polaris is on your horizon, go ahead and look due west. Okay, so if you look out at Polaris and you make like a little, like you can't even make any circumpolar stars, can you? You can't even make a whole circle. You can just make an arch, okay, go a little bit higher up on the horizon, make a bigger arch, make a bigger arch, make a bigger arch, and then what you're going to eventually do is from the east towards the west, you're going to make one big arch, okay, and then you're going to make smaller and smaller arches toward the South Pole, which is also on your horizon. Okay, so then looking due west, this is what you see. Okay, the stars coming from the east and setting in the west, coming from the east and setting in the west. That is so cool. To kind of emphasize what I was trying to say, so if we were to look over here towards the north, okay, towards the north, actually what you'd see is, this is Polaris, you'd see like little, kind of like little arches, okay, and they would kind of get more and more straight, and then they would be like that. So the last one, or last scenario I want to mention then, is this one, which is 45 degrees north latitude, which might be where you are. So basically, what you're looking at is our star trails like it would look if you're looking due west. So the stars, your local sky, vary with latitude. I always have to concentrate. They vary with latitude. Okay, so that's to say that if you're here, or here, or here, or here, if you change your latitude, you are going to have a different local sky. So local skies vary with latitude. Of course, here's this person's local sky, right here. Okay? But they do not vary with longitude. So this is to say that if you were, let's go ahead and zoom in a little bit more, let's pick on this person, you will see the same local sky, okay, if you are at different lines of longitude. Let's see. So if you are here, or here, or here, if you're different lines of longitude, okay, but the same latitude, you'll see the same sky. So local skies vary with latitude, but not with longitude. So an extreme here is picking not somebody at the North Pole, but picking somebody in the southern hemisphere, right? Okay, and this is their local sky. Specifically, this person is 34 degrees south of the equator. All right. So this is this person's zenith, and this is their local sky. Right? They have the different set of circumpolar stars. By the way, is this not cool or not? What? So let's go back to if you are at the North Pole. What are your circumpolar stars? Well, they're all circumpolar. Is that crazy or what? If you're at the equator, what are your circumpolar stars? You don't have any circumpolar stars. So one more slide with this part. So I have two figures here. One is in the northern hemisphere, okay, and the other is in the southern hemisphere. Okay, so in the northern hemisphere, our cool star, our important star, the star that we look to for things to go counterclockwise around, is the star called Polaris. That's our North Star right now. It hasn't always been. We'll talk about that coming up. But this is to remind you, how do you find Polaris? Okay, well, you look for the Big Dipper, which is an asterism of Ursa Major, Big Bear, and you use the two far bowl stars as pointer stars to point to Polaris. Okay, so here is the deal. Things are going to go counterclockwise. Oops, wait a minute. Oop, I wonder if it'll let me reverse that. No, it won't. Things will go, yeah, that was right, counterclockwise around Polaris. Okay, so that's why, see, here we have the Big Dipper here. 2 hours later, it's here. 4 hours later, it's here. And 6 hours later, it's here. I don't know if you saw all those. This is one, this is 2 hours after that, 4 hours after that, the original, 6 hours and 8 hours. 6 hours. Okay, so it is going counterclockwise. Now, in the southern hemisphere, they don't have a pole star, like I was saying, and I couldn't remember how they do this, but this is how they do it. They look for the constellation, the Southern Cross, and they basically take how long the cross is times 4 and go towards the center. So it's not really nearly as cool as having a star there, but it's not bad. So, but in the southern hemisphere, notice that the movement is clockwise instead of counterclockwise. Okay? So it's the same sort of deal though.